Good evening, Nano fam. Welcome back. Hey, Jubu. So, finally, time again to work on the Rust node. So, let me just quickly add you, Jubu. How was your week? And the week before, because I didn't stream last week. Hi, Undefnal. Hey, 1401. Rust time, yeah. So, we have on the spinner wheel, we have Wenderson, we have LF, we have Jubu on the spinner wheel, 1401. Hi Pius, how are you? Martha, that's a new name, hello. If you want to take part in the Nano giveaway, just post your Nano address here in chat, and then I put you on the spinner wheel. Yeah, so, exciting times again, exciting times. So the Rust port is really making good progress. Hey, Croptor, let's put you. Let's just have a look at the wheel so that you can have a look for yourself if you are on the wheel. And I think this time the sound, the Bitcoin block timer sound, I think it will work again. Okay. So where to start? Martha has sent her address. Okay, let's add you quickly. Yeah, I said it would be so cool if there was a chatbot for this, so that I wouldn't have to manage the address book manually. Martha, what was your name? Yeah, just Martha. Where is it? And your address, safe. Okay. So, do I have everyone now? Let's see. Edie Bob is here. Edie Bob. Okay. Wonderful. I am not on the wheel. Oh, I am not. You're not? You're not? Oh, I'm so sorry. Good that you are. That you had to look Undefnal. So, Mark Sano, hello. And there is your Nano address. Oh, so many new people today. That's great. Okay, let's add you too. Mark Sano. This is your address, right? Yeah. Okay. All right. So I hope I have everyone. The Bitcoin block timer is running already. So in 8 minutes, we will give away the first Nano to one lucky winner. And yeah, if this is your first time, we pick the 10-minute timer because 10 minutes is the block time of Bitcoin. Incredibly slow, and with Nano, the transactions, they go out instantly. So no 10-minute waiting with Nano and no energy wasting with Nano. We can just send it out cheaply without any fees instantly. Okay. So now I hope you are all on the wheel. If not, please let me know in chat. Where to start? So LF took some time and migrated the RsNano website, and it is now hosted by GitHub. Sorry, by GitHub. GitHub. What was the name? GitHub Pages, and that means that I can now just push commits, and it should update the site immediately. And let's try that. Oh, I don't have a terminal open. Let's try that. Let's push the current percentage. So we currently have, how much percent do we have ported? 53.03. So I think we just need to update one file. So now I'm going to break LFLF's work. .com. So it is, I think it's in the folder source. I've never done this. So this is unrehearsed. Lib. utils, progress. Here it is. Okay, so I think we just have to add one more entry for June and 53.03. And let's commit this. And let's push this. And let's check the website in a minute. Maybe this works, maybe. Okay, so let's go back to here, and let's run NeoVim. Okay, so I was busy merging upstream commits, and then I got sidetracked, and I spent quite a lot of time now refactoring the network code. And I think this is interesting. So let's have a look at what I've been working on. And I drew a diagram. By the way, nanomug. Today we are a double equipped. We have the nanomug and the nano ring. So that's just for good luck. Yeah, so I've been working on refactoring the network code, and where to start? So Piotr did a lot of work simplifying the network code, and I had to merge his changes, and that got me into trouble. So his changes are generally very good, so they simplified the code a lot, but they are still not Rust idiomatic, and they brought me into a lot of trouble because I had refactored the network code already, and then I had to merge his changes, and that was really difficult. And yeah, then I got sidetracked, and I thought I would just rework the network code so that it is, yeah, it suits better the Rust way of how to program. Andefla says, what? A nano ring? Never seen one. Yeah, I bought it, I think 2 years ago or 3 years ago. The ring to rule them all, yeah. Still waiting for the RsNano merge drop. Yeah. LFLF, I know. I should sell mugs. I should do that. Maybe as a limited edition. Yeah. So maybe let's check out the C++ code as it is right now. And this is just a very simplified version where there are multiple components, and I made them different colors. So we have a TCP listener. The TCP listener is opening up a port and just waiting for other nodes to connect. And so it's a passive, it's just listening, waiting for other nodes to connect. And then there is the TCP channels class. And this class contains all connections. And this is already like where it gets complicated. So the TCP listener has a list of connections, which are the incoming connections. And then those connections are, as far as I have understood, also in the TCP channels class. And the TCP channels class, yeah, it's just a container of all connections that we have to other nodes. And they share the same kind of rules. So there's code duplication here, and as you can see with all the arrows, there's a lot of circular dependencies. So arrows going left, going right to the node and back. And yeah, that just doesn't work with Rust at all. So I worked a lot with the goal of simplifying all of these dependencies here. Also the TCP server, I found that one a bit confusing. So what this is, it is actually listening to only one connection, one channel, and it responds to certain requests. So another node can send us a request and the TCP server will respond to those requests, but only for a single connection. And I renamed all of that because I had troubles with the names. So for example, the TCP server, I always thought the TCP server was like a server responsible for multiple connections. And that always, I found that confusing. And also the name TCP in there, I thought it would be about TCP stuff. But actually this is not about TCP at all. So this is just working on the message level. So it is receiving messages and responding with messages. And there's no TCP stuff in there really. So I renamed these classes and I hope these names are better. Let me know, chat, what you think. Not confusing at all, says no. So I renamed the TCP server into... Oh, did you hear it? Now the sound works. TCP server without TCP stuff, yeah. So I renamed it to response server, and I'm still not super happy with that name. Maybe I will call it something like responder, message responder, channel responder, something like that. And this just receives messages from another node and it will respond to those messages. And let's just do the giveaway first. So the first nano goes to Wenderson. Nano is the light. Congratulations. One nano. Unlock. There you go. Okay. Congrats, yeah. So yeah, I renamed the TCP server to response server. It's not still not a good name, I think, but at least for my head it works better. So now I know it is not about TCP, and it is actually just sending responses. And with that name, at least I remember that this is just for a single connection. Yeah, so such a connection is called a channel. A channel where we can read and write. Just we can send messages with a channel. And I renamed the TCP channels class into network, because I think this is just shorter and also a suitable name. So the network struct is now responsible for all channels that we have to other nodes, managing all of them. And this is now different between the Rust and the C++ code, because in the Rust code we have this one class and it has a list or a container of all channels, and in the C++ code we have kind of a double bookkeeping. So the TCP listener manages the connections that it receives, and those are also copied, I think, to the TCP channels, but I think they are still there too. And both check for the same rules, I think. So there are certain rules, for example, that you cannot connect more than X amount of times from the same IP address, for example. And I think those rules are checked in both classes. Not sure really. I'm not very familiar with the current state of the C++ code. But there is certainly code duplication here, and there's certainly a double bookkeeping really, or two containers for open connections, one in the TCP listener, one in the TCP channels. And I thought this is confusing, and so I simplified the design so that the TCP listener is a lot smaller now. The TCP listener only opens a port and waits for connections to come in. and then it passes that connection to the network struct, and that is the only place responsible for keeping track of it. So we have all channels in here, and that meant that I had to extend the channel a bit. So the blue box here is the channel. So yeah, a channel just has like read and write where we can send messages. And I added the channel mode to the channel, and the channel mode tells us which mode the channel is in. So when we create a new channel, it is in undefined mode, so we don't know what this channel is about. And when this channel receives bootstrap messages, then the mode switches to bootstrap. So these are the two basic modes that a channel supports. We have the bootstrap mode for bootstrapping, and we have the real-time mode for real-time traffic. And real-time traffic is the vote traffic and new blocks and all of that, all of the communication that our nodes have. Underflow says, it looks like there are a lot of circular dependencies in the C++ code. Yeah, there are a lot of circular dependencies. Is this normal for C++ code base? No, I wouldn't say so. I think this is just in the Nano repository, and certainly others. But yeah, this is it is easier to make this in C++, and in Rust you would have a really hard time, and that's a positive. So I think it's really good that it is so hard to create something like that in Rust. Yeah, so I added the channel mode to the channel, and I also added the channel direction where we can say whether the channel is inbound or outbound. And all of those channels, they live in the network struct. And this network struct makes sure that those channels are alive, and if they are not alive, the network struct will kick them out, for example. And I had to change a couple of things here, because in the old way, the network struct, so that's equivalent to the TCP channels class in C++, it only kept real-time connections. So there were no bootstrap connections in there, and there were no connection attempts in there, and no handshaking connections in there, and now they are all in the network struct. Underflow says, it must be so hard to reason about the C++ code with those dependencies. Oh, it really is. It really is. And also porting that to Rust is really hard, because, yeah, obviously you can't just port it like it is. So you have to get rid of those circular dependencies first, and then you can port it to Rust. And that is really tricky and took me a lot of time. Okay, so that's the current state that we are in right now. We have the TCP listener listening for incoming connections. We have the network struct managing or just containing all of the open channels that we have. And this box down there, we haven't talked about that one. I introduced this. This is new in Rust, and it is not there in the C++ code. It is called, I called it the node connector. And the node connector is responsible for connecting to another node. So these are two ways nodes can connect. The TCP listener is passively waiting for incoming connections, and the node connector is actively connecting outbound. And for the channel itself, it really doesn't matter. It doesn't matter whether the channel came inbound from the listener or whether we made the connection with the node connector. It's just for the node, it's the same thing. It's just a channel, and the only difference is that we have a channel direction property here where we can look up whether it is an inbound or outbound channel, but it behaves the same. And yeah, so this is not there in the C++ code. And the reason why I had to split the node connector out of the network struct. So let's just go to the C++ code again. So connecting to another node is done in the TCP channels or in the listeners. They both have a connect function, and it does the same thing. So you can call listener.connect and connect to another node, or you can call TCP channels connect, or it's called merge peer, I think, and it will connect to another node. So both have this responsibility. And I couldn't do this in Rust because when we connect to another node, we also have to create this response server, which will respond to the messages, as I said. And the response server obviously has a lot of dependencies. So this has dependencies to the block processor, to the ledger, to whatever. So this thing has a lot of dependencies, and it should be created. So that means the node connector should be created at the very end of the node startup. And the network class is used everywhere, so this has to be created at the very beginning of the node startup. And so we can't have that connection responsibility in there, because we create the network first, and then we create all of the other components. And that's why I split it up into two parts. And I think this is also good for the single responsibility principle. So the network is responsible for managing those connections, and the node connector is responsible for for initiating a connection, for creating one. And then once the connection is created, we just put it into the network struct. Okay, it's time for another round for the spinner wheel. One nano for Underfnall. Congratulations. Oh, what happened here? Underfnall. Congratulations. So the timer is running. No, is it? Yeah. Underfnall says congrats, Underf. LF says rigged. Yeah, it's rigged. It's rigged. But it's the old wheel. Underfnall says received even before he clicked it. That was fast. Yeah, time travel is the new feature of Nano. Oh yeah, let's reload the website and see whether yeah, it worked. On the first try. Yeah, so there's not much progress percentage-wise. But that is because I'm currently not porting code. I'm currently refactoring the networking code, and I'm currently merging the upstream commits. So this will stay at 53% for maybe a couple of weeks, and then it will go up again, I think. Good. Okay, let's go back to the diagram here. Okay. So, do you have questions, NanoFam? So, it's still, the Rust code is still not in a place where I would call it good. Not at all, really. So the refactoring that and making it nicer is really time-intensive task. And it's difficult, really difficult to do for me. So I expect to work a lot more on this until the code comes into a shape where I would call it simple and well structured. But we go in small and simple steps. So that's usually the way I work. So small steps, simple steps, and if we just keep improving and and sum up all of these small improvements, we will actually achieve a big improvement. Colin says, at least we stopped bombing you with upstream commits. Oh, yeah, but I think I'm afraid, actually. I am afraid that this is just the calm before the storm. So that was insane. Like the team was working insanely hard, like a lot of commits coming in, and I was actually more than 200 commits behind last week or 2 weeks ago, and now I'm 110 commits behind, and yeah, it's just insane. So many commits, and it's a good thing. Like I'm not complaining. So if the C++ node is advancing so quickly, it's a good thing. And also all of those improvements, they eventually will land in the Rust node too. Underflower says, commit carpet bombing. What is carpet bombing? Okay, yeah, so for today, I don't know actually what I want to do. I thought that I would work on the tests, because I deleted tests while I was merging Piotr's changes to the network code. And I usually don't like to delete tests because those tests are important. But I was in a bad situation because the code changes were so intense, so how to say, that there was so much stuff changed that I could not keep the tests compiling. And then I decided, because I always wanted to rewrite those tests anyways, so I decided to just delete them so that I could finish the merge. And now I still have to re-implement them. So let's open up the file network.cpp, and let's have a look at all of those deleted tests there. So I added to-do comments. Oh, wrong file. Node CPP, network CPP in core test. So these are the network tests, and I have, for example, this one I deleted, and then I just wrote to-do re-implement in Rust. And there's this, and this, and this, and this, and this, and this, and this. So quite a lot of tests here that we have to rewrite. And those tests are also flaky tests. So this one, send node ID handshake, it is disabled. Or I disabled it because it never passed for me once I switched to Tokyo. And the other tests also are... Here, these tests are also flaky. I think they are also disabled in the C++ code because of this comment here. And yeah, so I thought maybe for today we can focus on re-implementing some of these tests, and as real unit tests, and not as integration tests. What do you guys think? Let's have a look at this one. Disabled, yeah, so send node ID handshake TCP. So let's have a look at this test in the C++ code, so that we know what it does. And then let's try to write the same test in Rust. So let's go to network.cpp. And let's search for the name. What was the name? Send node ID handshake TCP. So send, no, here we are. So this is the test that I deleted. And what does it do? So it creates node 0 and node 1. So it creates two nodes. And then this line initiates a connection between node 0 and node 1. So as I showed in the diagram, in C++ it's called the TCP channels class, and in Rust it is now called just network. And the start TCP, this is establishing a connection. So in the Rust code we would need to call how did I call it? Let's just have a look here. Node connector. So this one here, the node connector. And then it asserts network size 0. So this is already looking flaky. So if we call start TCP, we assume that it is just so slow. The connection thing is so slow that the network size is not affected yet. Then it waits for maximum of 10 seconds for a node ID handshake to come in. Okay, and here again for the other node. And what is that? A keep alive. It also waits for the keep alive message. Yeah, so I want to split this test up because this tests a couple of different things. Now it tests that the network size is 1. And what are these asserts here? It asserts that this is a TCP channel. Okay, it asserts the correct node ID. Okay. Yeah, so I want to split this test up because this tests many different things. So it tests that we can establish a connection. It tests that the node ID handshake is sent. It tests the keep alive, and it tests here the node ID stuff from the handshake. Okay, so let's switch to our Rust code and let's think about how we could write those tests in Rust. So let's focus on the handshake. We sent the handshake in. Yeah, let's go to the response server class. And let's see, where do we send the handshake? I think there is a function for sending the handshake here. Initiate handshake. And I already extracted all of the handshake code into its own struct. So in C++, all of the handshake code is in the TCP server class. And there's also a lot of other stuff in there, so I separated that out into its own struct. And I called this struct handshake process. Oh, time is flying by. Another spin. LFLF says, sounds like a plan. Will you use the nullable strategy again? I will eventually. Oh, Wenderson won again. I will eventually use the nullable strategy again. But currently I would have to refactor the code so that we can use nullable TCP streams. And it's just not there yet. Okay, new Bitcoin block appeared, so let's reset, yeah. Wenderson, yeah, today I'm on fire. Yeah, 2 nanos, 1 already. Nano is the light. Yeah, so this is the handshake process, and I just moved all of the handshake code into this one. And this also has to be tested, so I think some of those tests that we have to rewrite will end up here. Okay, so here we are in the response server. Oh, this is still called impl. Don't mind that, chat. Just, yeah, so this is the response server. And it calls the... So I want to write one... So let's think about this. How do we want to test this? I want to write a test that initiates the handshake if it is an outbound connection. Because that's how it works. If we initiate the connection, we have to initiate the handshake. So let's write one test that if we initiate an outbound connection, that the handshake process is started. So that's just one test. And Same for the inbound connection. We have to test that when we add an inbound connection, that we wait for the handshake to be initiated. So let's focus on the first test, the active part. So we add a connection to our network struct, and then it has to call the initiate handshake function. And yeah, let's do this with nullables, because I think many projects would use a mock here and would assert on the mock, and I don't want to do that because mocks, as we talked about that a lot in the previous streams, mocks have a lot of issues. So I want to use the production code, and I want to just test that this initiate handshake was called. And here's the code even. Can you see that, NanoFam? So it checks if it is an outbound connection, then it calls initiate handshake. And of course we have to test the handshake stuff in there too. And I will write tests for that, but let's start with just that this is called. And what is that function here? We are in the network struct. Yeah, add. So network has an add, and it takes the socket, the response server, and the channel direction, so that we know if it is an inbound or an outbound socket. Okay, and where does it call the initiate handshake? Here. So let's go to the bottom and let's add tests module. Tests. And we use super. And now we say test. And how do we name this? Initiate handshake when outbound connection added. So this is what we want to test. So we need a network. And now our trouble begins, because network still has a lot of dependencies. I have not refactored. Oh, there's a new null already. I have created a null version already of the network. I thought I didn't. That's good. So we are not in trouble, NanoFam. Everything is fine. So we create a network, and then we call add. So we add a connection to the network. And we need a socket, and we need a response server. And what else do we need? A direction. So let's say channel direction. Inbound, outbound. So of course we don't have a socket and we don't have a response server yet. So let's create that. Socket is what is it? Is it an arc? Yeah, it still has to be an arc, unfortunately. So all of those things will change in the future. So arc new socket. Does that have a new null? No. Create null. Oh, why is this called create null? And the other one is called new null. So let's rename this to new null. So the names should be consistent. Okay. So we create a new socket, and we have to create a response server. So let's say that response server is equal to, what is that type? Arc. Okay, so arc new. All of those arcs. What do you think? Will we get rid of those one day? I certainly think so. So response server dot Impl. Oh, response server does not have a new null. It just has a new function. Oh my goodness. Oh my goodness me, look at how many arguments it has. Look at that, chat. That's ugly as hell. Ooh. And I don't care about any of those dependencies. I don't care about any of them, because the only thing... So I want to... Let's just move down here. So the only thing that I want to test is that the response server initialize... No, what was it? Initiate handshake was called. That's the only thing I want to test here. So maybe let's create a new null. Let's create a new null function that doesn't take any arguments. Okay, so let's create a new null. Yeah, let's create a new null function here. Oh, so many things here. So many dependencies. That's really bad. But don't worry, I will refactor it one day. So let's fill in all of those fields that we need. So we need an async runtime. Let's just create one. Oh, it just needs a weak pointer. LFLF says, just check the RsNano codebase and you have multiple places where you call create null instead of new null, by the way. Oh, thanks, LFLF. Should we fix this right now? Let's search for create null. Oh, yeah. Oh, there's a couple. Oh, thanks, LFLF. Okay, so I don't want to mix this up with the tests that we are currently writing. I will fix this on Thursday. So, async runtime, weak pointer. So a weak pointer. Let's just create one. Let's create a weak pointer too. An async runtime. Async runtime. Default. And it needs a channel. Mute. Oh my goodness. Mutex option. Arc. That's just... Yeah, let's spin the wheel. That's just ugly. Oh, who is it? Who is it? Who is it? It's Ely Bob. Congratulations, Ely Bob. So let's just wait for a couple of seconds to keep the to not send out the nano before it is streamed. How much is the delay? 10 seconds? 20 seconds? Okay, here you go, Ely Bob. 1 nano. Okay, yeah, channel. What was that? A mutex option. So let's say mutex new non. What is socket? Arc socket. This is so bad. New null. At least we have a new null here. Config is an arc node config. Arc. Node config. Stopped. Atomic bool. Disable bootstrap listener. That's just a flag. True. Let's just say disable. Connections max 1. Remote endpoint is a mutex again. I think I have... Do I have a test? Test endpoint, yeah. Network params. Let's also use default or something like that. Network params. There's no default for network params. But there's a new... Okay, this just takes one argument. Networks. Def network. Last telemetry request is also a mutex. Non. Unique ID. 42. Stats. No, is there a default or a new null default? Disable bootstrap server. Bulk pull, yes. That's just all things should be disabled. Message visitor factory. Uh-oh. This sounds like something that takes a lot of dependencies. Oh, chat. Oh, this is ugly. Okay. I'm also adding a new null. What is message deserializer? Arc message deserializer. New. Oh. Protocol info work thresholds. Network filter buffer reader. Really? This is horrible. TCP message manager. What else do we have? So the others network? Weak pointer to network. Weak pointer to network, even that? Handshake process. Oh. This is... Oh, this already returns an arc. Okay. Oh, Nano fam. We are in a lot of trouble. So how can we... Does this even help us? So I could maybe try to add a new null to all of those. Let's try this, yeah. Let's add a new null to all of those. TCP message manager. Arc new. TCP message manager. Oh, okay, so this just takes one argument. That's good. Allow bootstrap. Let's say no. LFLF says, this really needs some refactoring. You're right. A single class should not have this many arguments. You're absolutely right. This really needs some refactoring. Notify stop is a notify. What is a notify? Oh, this is from Tokyo. Last keep alive. So many mutexes. Node ID is a key pair. Protocol info, let's just take protocol info default. Network is a weak pointer, so let's say arc downgrade arc new. Network. New null. And handshake process. Oh, so this also needs a new null. Yeah, this is really ugly code right now. But it doesn't have to be perfect from the first, from the start. It doesn't have to be perfect. So we will improve it in small steps and we will resolve this mess. So now we have to create new null in these three structs: the bootstrap message visitor factory, the message deserializer, and the handshake process. And then let's see if we can run the test then. So let's add a new null here. New null. I'm not so sure if this is a good idea to create multiple async runtimes here. But let's just try if this works, and it will be better anyway. Anyways, in the future. So let's add that stats, another stats, node ID. This is a key pair. Yeah. Network constants. Empty? What is empty? Okay. I'll take it. Ledger. I think there is a ledger new null that actually creates a nulled ledger. Yeah. So this is now actually a nulled ledger, so a ledger that doesn't write to the file system. Oh, what? Oh, there's a comma missing. Thread pool. A weak pointer to a thread pool. Downgrade. Test instance. Block processor. Also weak pointers. So many weak pointers here. And what is wrong here? Oh, is this... Maybe I have to say thread pool. There's an arc. Then thread pool. Then we have to initialize it up there. Like that. Yeah. Block processor is a weak pointer to block processor, so also arc downgrade. New test instance. Oh, this also needs a ledger. Let's move the ledger here. And let's say ledger.clone. So bootstrap initiator. So many weak pointers. Yeah, let's spin the wheel first. Is it Wenderson again? Is it? Oh, that was close. RsNano won his first nano. Congratulations, Mark. So 5 nanos still. Almost rigged, yeah, almost. That was really close. That was a off by 1 error of the rigging code. So bootstrap initiator, downgrade, arc new. So let's create a bootstrap initiator. And flags. What is flags? Just node flags. Okay, another new null missing. And the bad news is that this could actually not work, because I'm not really nulling it right now. I'm just creating an instance, and that instance is not really nulled. So maybe what we're doing here is that won't work. Again, so many dependencies. This is this dependency hell. Oh, this is really bad. Connections, bootstrap connections. Maybe this was a bad idea. I mean, the alternative we have is we could introduce interfaces and write our own stubs. Let's just try this out. Let's just add another new null. And let's see where we end up. Maybe all of that is just a bad idea. No. So what is mutex? Mutex data. What is that? That doesn't even have a new function. What does it contain? Attempts list. What is that? Hash map. This condition is a cont var. Read some mutex with a vec. Connections. Oh, another new null. Missing. I regret that we went down this path. Also, this naming is wrong. This is called node config new null, but it should be new test instance, because there is no infrastructure in the config. So we are not nulling anything here. So nulling meaning disabling the infrastructure. So this is just creating a test instance. So this should be called new test instance and not new null. Atomic bool. Cache. Pulse cache. What an arc mutex. Pulse cache. Stats again. Attempts is also an arc. Mutex new. What was it? Bootstrap attempts. Okay, so far so good. WebSocket can be none. Block processor has a... And here, I think here the naming is also wrong, because this is called new test instance. But this is actually should create a null block processor. So this should be called new null. Let's create a new null here. Something that doesn't take a ledger. And for now, I'm just calling new test instance with arc new ledger, null ledger. And null. Okay, and here we still have to create the ledger with new null. You know, NanoFam, the worst part will be if we spend all of those minutes writing that code and then it won't work. And then everything we did was for the trash can. Network, params. Flags. Fault, network. And workers, another thread pool. Okay. Root sub connections doesn't have a null. How many more? More. How many more? That's just a bool, an atomic bool. What is that? Attempts, arc mutex. Few minutes until we send out another nano. Let's try attempts. What is that? Bootstrap connection starter. LFLF says, how are there so many arguments? Yeah, it's horrible. I know, it is absolutely horrible. Yeah. The code base is far from nice. Currently. Far from nice, but I'm working on it to clean all of that up. So many dependencies. You know, that so many dependencies is actually an outcome of this design of the C++ node, which makes it so easy to introduce new dependencies. So if we have a look at the C++ code design again, you see that all classes depend on node. And node has itself a dependency to everything else. And with this design, it is so easy to introduce all of these dependencies because you just every class has the node, and if you want to access another instance, all you have to do is just go node.channels, node.ledger, node.block processor. So it's just the code itself does not make it hard for you to introduce new dependencies. And that's the reason why we have so many dependencies now. And I made all of those dependencies explicit. So I don't pass around the node in Rust. So I actually pass the dependencies that a class have needs around. And that's a lot. And so the mess you see here is just the explicit mess that is implicit in the C++ code. Another giveaway already. Wow. Time flies. And this time the nano goes to, oh, pice, that was really close. This time it goes to 1401. Okay. Congrats, 1401. So, config, node config, new null, connections count. I hope we can get to a place where we can compile this mess. New connections empty. Stopped. Network. Flags. LFLF says, looking forward to the clean code version already. Oh yeah, but it will take a lot of time. So usually cleaning up code takes a lot of time. Workers. Red Bull. What? There's a create null and there's a create test instance? Oh! This one is actually nullable. I forgot about that. I have a really a null thread pool with a null timer. Why does the thread pool have a timer? Oh, because there's a delayed task. Okay. Okay. Async runtime. Network params. So, a socket observer. I think that I have a null one there. Yeah. And stats. Sorry for this boring stream. I'm just trying to get this to compile, and then if the test doesn't work, then I'm screwed and I have to undo everything. A bad situation. Log processor, new null, outbound limiter. Okay, this has a default bootstrap initiator again. Mutex weak pointer, some mutex new. What was it? A mutex option, so let's say none. And pulse cache. The last one here is a mutex, arc mutex. And arc mutex. Pulse cache. Oh. Okay, let's run cargo check. Okay, we forgot a new null in the handshake process. So let's add that. So we need a Genesis hash and block hash from 1. Node ID is a key pair. So key pair from 2. Syn cookies. Syn cookies. You. And stats. Handshake received. So this is easy now. Remote endpoint is just a socket address. And protocol is just protocol info. Okay. Let's check again. Oh, Colin wrote something in chat. We had a similar problem when removing the coupling to the node class in the C++ code. You have to pass a ton of arguments in, yeah. Usually logger, stats, ledger, etc. Yeah. Yeah, and I have that problem a lot right now. So all of these arguments, yeah, simplifying this is a very hard task. Message deserializer. New null missing in message deserializer. Message deserializer. New null. LFLF says, I'm a fan of breaking many arguments like that into multiple smaller helper classes that wrap related properties, but it's not applicable everywhere, of course, and has its limits. I'm fully with you, LFLF. So yeah, so I think the divide and conquer strategy and also hiding information is the way to go here. Yeah, because usually if you have a lot of dependencies, it can mean different things. It can mean that your separation of the problem is incorrect, so that your classes do too much. It could also be that your dependencies are overly separated. So some of them could be joined together into one class maybe. Or sometimes they are just they should be hidden by a more generic abstraction. And maybe we can bring some of those dependencies together into one class that is delegating them to them. And it really depends. There is really no answer for all of them. Colin says, yeah, difficulty to test is equal to problem somewhere. Yeah. Yeah, usually if it is difficulty to test, there's usually a design problem. New null. Oh, so I have to return this here. What is this message deserializer? So this takes a network filter, and all of those args are really bad. But yeah, I had to add the args because otherwise I don't know how I could have made that interoperable with C++. And now the C++ is still there because the tests are still in C++, so I have to keep the args right now. So network filter, arg thresholds. Is there... What is this? Epoch? I don't care. How about those values here? What call info? Read buffer, arg mutex vacuate. Buffer reader is T. What? Oh, this is generic. What? Oh, okay, so the T is here. Buffer reader. Async buffer reader. And what is the buffer reader? What implementations do we have? Vec buffer reader and... Ooh. Okay. Ooh. I have to move this... buffer reader. Why doesn't... Oh, impl... Wait a minute. How does this work? Back buffer reader? How does this work? Back buffer reader. Can I say impl buffer reader? No? Where is back buffer reader? I think it's in public. It's in channel in proc. Ugh. Let's make it public. And now let's move the new null up here. What is buffer reader? T. There it is, a new. Oh, maybe the new is not public too. Yeah, new. Okay. Oh, okay, so the type is arcsocket. Oh, okay, so all of that was bad. So arcsocket is the type. So what is the buffer reader then? We have to say arcnew socket. Oh, this returns an arc already. Like that. Okay, let's check. Oh, and let's spin the spinner. RsNano won again. Congratulations, Mark. One nano for you, sent instantly, without any fees, and eco-friendly. Oh, okay, so we don't have any errors anymore. So let's run the tests. And hopefully this will not panic. Hopefully this will not panic. Because then we can finally continue with the test for the handshake initiation. LFLF says, congrats on getting through this constructor hell. Yeah, thanks, but we don't know whether this was actually a good idea. Because it could be that we now run into panics, and what to do then? What to do then? Come on. It's taking forever. Okay, so that looks good. So at least it didn't panic. So I think we can now go back to the test. Where was it? Response server. No, it was a network. Down there, yeah. And yeah, so we called network add. And now we want to the assert is missing. So we want to assert that the initiate handshake was called in the response server. So to do assert that initiate handshake was called. So how to do that? And I want to do this with output tracking from nullibles, from the nullable testing without mocks pattern language. So we need a way to track whether this function was called. So let's add that to the response server impl. And let's also write a test for that. So let's add a test down here. And that test says can track initiate or can track handshake initiation. Initiation. So let's create a response server. Let's create a null one. And now I want to say handshake tracker is response server dot track handshake initiation. Like that. And this will not compile because there is no track handshake initiation. So let's add an output tracker just for that. So let's add an output listener. Should this be done here or should this be done in the handshake process struct? Let's think about this. Should it be done here? I think it should be done in the handshake process struct. Or maybe not. Let's start here. Okay, so we need a listener. We need a handshake. Initiate handshake listener is a output listener multi-threaded. And what is the data? The data. Is it chat? Is it called data or is it called data? We don't need any data. We just need the information that it was called. So like that. The letter says LF data. Okay. Data. So let's initialize this. So this output listener is something that I wrote. And it is just an implementation of the output tracking pattern of the nullable testing without mocks pattern language. So what was it? Handshake listener is an output listener new. And then we can add the track function. Track handshake. What was it? How did I call it? Track handshake initiation. And it will return an output tracker. And this will just call initiate handshake listener track. Mismatch types output tracker empty. Oh, an arc. This will return an arc. Okay. New null. Okay, the null also has to initialize that. Output listener. Okay, so now we have that tracker, and now we can assert that when we call response server dot initiate initiate handshake. Oh, this is an async function. So this has to be an async test. But await. And then we want to assert that we want to assert that our handshake tracker contains one output, which means which just means we called the initiate handshake once. Does that make sense? Let's run the test and let's see. Oh, and I made a mistake. I should have. No, I didn't make a mistake. I just thought it would be green, but it will not be green because we didn't actually emit the handshake, the initiation event. So this test should fail. And we have what is that? Oh, we have a panic. That's bad. That's not the right failure. We have a panic here. Panicked because shutdown. Oh, let's spin the wheel. So that's one for you, LFLF. One nano for you. And if not, that's rigged, yeah. Cannot drop a runtime in a context where blocking is not allowed. This happens when a runtime is dropped from within an asynchronous context. We are in a mess. That's really bad. Where was the panic? It was in the shutdown. Runtime shutdown. Cannot drop a runtime in a context where blocking is not allowed. A runtime is dropped from within an asynchronous context. Yeah. Yeah. So the problem is that we created all of those asynchronous runtimes. And that was just a bad idea. Here, the new null creates its own runtime. Colin says, sounds like async code is being called within a sync function. Yeah, so it's even worse. So we have multiple async runtimes, and we drop one of those async runtimes within another async runtime, and that just doesn't work. And the whole idea was actually stupid. The whole idea of creating multiple async runtimes was actually stupid. But I just wanted it to get to compile, and but this is definitely not the way to go. This is not the way to go. Why does it have this async runtime? What does it do with it? Can we maybe get rid of it? Start. What does it do here? Is this the only place where we need it? Yeah, so this is only used in the start function. And then it spawns a task. So maybe we could make this one async, and then we wouldn't need the async runtime. We could try that. Because here we have a field. Here we get it from the constructor. Here we create it in the null, and here we use it. So maybe let's make this one async. Who calls the start? Oh, so many places. Oh yeah, chat, that's another design issue that I want to change urgently, because this is so confusing. So this is about the bootstrap servers. So there are different bootstrap methods or strategies, and the problem with those is they start bootstrapping, so they create messages and they send a message after message after message. And while the bootstrap server returns data, no other incoming messages of that channel will be processed. And this is done by stopping or by pausing the channel. And once the bootstrap server is done, it has to restart the connection. So it has to restart the response server to receive new messages. And this is again a circular dependency here. And all of the different bootstrap strategies work like that. So they all call connection.start when they are done. And I don't want that, because this line, the connection.start, it introduces a circular dependency again. What I would rather have is, I want the bootstrap server to be asynchronous, and it would just have an asynchronous run function, and we could await for that, and this could then just send all of those messages, and it could take a long time, and then the connection would itself continue then receiving new messages, and we would not have to remember to call start in all of those bootstrap strategies. So that line is problematic. Yeah, so start. So let's say we make this one async. What then? What then? What does it do again? It spawns a task, receive messages. Response server, start. And this is receive messages is this a long running task that just keeps on looping? Yeah, so this loops and just keeps on receiving messages until the whole connection is stopped. Okay. Maybe we should we make this async? Then we can get rid of the async runtime completely, and we would get rid of our problem. And then what then? This calls. Maybe we can rename the start to run. Let's try this. Maybe we can rename this to to run. And we make it async. Oh, before I do this, let's just check all of the Bootstrap servers again. Do those have access to the async runtime? They don't? What about this one? Oh, none of them have access to the async runtime. Oh, okay. Bad situation. Hmm. Hmm. How can we fix this mess? How can we fix this? So I only see two ways to fix this. The one way is to not make this a Tokyo test, to not make this an async test. Or we make or we remove the async runtime from the response server. And removing the async runtime from the response server is something that I wanted to do anyways. So that would be, I think, the right direction. But we can't do it right now. We can't do it right now. It is because all of those Bootstrap servers, they don't have access to the async runtime. And we can't currently call async code from the Bootstrap servers. But yeah, eventually all of those Bootstrap servers have to be async too. So maybe I should abort here and maybe focus on the Bootstrap servers first. Let's spin the wheel. Jubu, you won. 1 nano. Congratulations. And only 1 nano left. And then before the stream ends, 1 nano is left. Oh, Nano fam, I don't know what to do. I don't know what to do now. This whole stream is a clusterfuck. Really, really, really. And if not says me neither, I'm going to sleep. Yeah, have a good night. I think I'm going to sleep. Too tired to watch. See ya. Yeah, I'm also tired, and this is now a dead end. This is a dead end right now. A simple test like this can't be written currently because of all of those horrible dependencies. Yeah, you know what, NanoFam. Let's call this a failed experiment. And I have to rethink how I want to continue here, because this just doesn't work. And I think probably I have to add async capability to the Bootstrap servers first, and then I can remove the async runtime from the response server. think that's the way to go. So, yeah, let's call this a failed experiment. And there will be no stream next week, and there will be no stream for at least 2 weeks, 2 or 3 weeks, because I'm going on vacation, and there's yeah, I'm going on vacation and I won't be able to stream. So so no streams for, I don't know, 2 or 3 weeks, unfortunately. But then I will come back refreshed, and hopefully we will not end up in a mess like this anymore. Okay, NanoFam, it was, yeah, it wasn't fun. No, this time it was hard. This was a bad situation, but it was still fun. Yeah, it was still fun. Have a nice week, and LFLF says, well, vacation sounds great. Enjoy your time. Thanks, LFLF. I'll keep you updated on Twitter and on Discord, so join the Discord server if you haven't already. Yeah, click like and subscribe if you are on YouTube, and see you all in 3 weeks. Have a great time. Bye-bye.